Good morning, students. Today we are going to learn an important concept in client-server computing called interprocess communication, shortly known as IPC. Interprocess communication is a set of methods provided by the operating system that allows different processes to communicate and share data with each other. First, understand what a process is. A process is nothing but a program that is currently running in the system. Since multiple processes run independently, they must communicate to perform tasks together. This communication is achieved using interprocess communication only. Why IPC is needed? Processes do not run in isolation in real world system. They need to coordinate, share information, and work together. For example, a web browser sends a request to a server. It's nothing but when you open a website, the browser process communicates with the server process. That is the thing. MS Words uses data from MS Excel. When you embed an Excel chart inside a Word document, two applications communicate. The third one is multiple users access the same database at the same time. In banking systems, multiple users access the same database concurrently. These are some of the examples of interprocess communications. IPC has number of communications, that is an interprocess communication. There are different types. First one is anonymous pipes, semaphores, shared memory, message queues, dynamic data exchange, remote procedure called message-based communications, object linking and embedding. These are the different interprocess communications. Let's see one by one. First one is an anonymous pipes. It is used to communicate between parent and child processes. A pipe is a unidirectional communication between the processes. That is a parent process and a child process. It allows data to flow in one direction, like water in a pipe. Pipes are mainly used between parent and child process. Here are some of the advantages of this anonymous pipes. It is an one-way communication. It is very fast. It uses memory also. It is temporarily acts, but in the execution time only it will allow the pipes. It is also a multitasking system. It is used in multitasking. These are the anonymous pipes. The second one is a semaphore. Semaphore are used for process synchronization. They control access to shared resources and prevent conflicts. Semaphores are very important when using shared memory using IPs. These are the advantages. Prevent simultaneous access, avoid conflicts and raise conditions. There are different types of semaphores is there. Binary semaphore and counting semaphore. It maintains data integrity. These are the semaphores in IPC. The next one is a shared memory. In shared memory, IPC has two or more processes access the same shared memory area. One process writes data and another process reads it. This method is very fast because data is not copied between processes. But synchronization is very important here to avoid conflicts. Here, with communication is very fast. Process read or write directly. It, it requires synchronization. They are used in real-time systems. These are the SAD memories in IPC. The next one is a queues. Let's say message queues. Process sends message to a queue. One or more process read from it. In message passing, process communicate by sending message to each other. The operating system manages these messages. This method is safer and easier to implement than shared memory, but slightly slower. Here some of the advantages are there. Synchronized communications. It manages it stored in a queue until it reads. support multiple senders and receiver at a time, used in servers and distributed system. These are the queues in interprocess communications. Next one is a dynamic data exchange. Chats data dynamically between Windows applications. There are different types of links, hot links, that is an auto update, warm link, update on request, cold link, manual copy. Here is an example, data in Excel updates automatically in Word. These are the dynamic data exchange. The next one is a remote procedure call. Calls a function on a remote computer as if it is a local system. A client can request it through the remote server. That is a function call. The remote server can get a result to the client. This is the RPC. It works across networks, hides communication details from user. It supports different systems and languages. It is an location independent. These are the RPC in inter-process communication. The next one is a message-based communications. In message processes communicate sending and receiving messages. No shared memory required here. Just directly it can sending and receiving through process via operating systems. It is safe and reliable. Used in modern computer operating system and multitasking environment. These are the message-based communication in IPC. The next one is an object linking and embedding. It combines objects or data from different applications, from Word document to Excel chart. For example, insert an Excel chart into a Word document. The data remains linked. It improves productivity used in MS Office applications. These are the some of the interprocess communications types. I conclude IPC is essential for client server environment. Without IPC, process cannot cooperate, share the data, or perform complex tasks. Understanding IPC helps us design efficient, multi-process, and distributed applications. Thank you. Happy learning.